All right, let's just dive right into this explainer. We constantly hear all these wild science fiction tropes about killer robots or machines waking up and becoming sentient, right? Well, today we're going to completely strip all of that away. We are going to look at what artificial intelligence actually is by breaking down the complex architecture of modern intelligence. Basically, our goal here is to answer a pretty fundamental question. What is AI? We're going to explain it in brief, but definitely with the depth you need to truly, really grasp it. So I want you to really think about something for a second. How many times have you interacted with artificial intelligence today without even realizing it? Seriously, if you're like most of us, you've probably engaged with AI dozens of times since you woke up this morning, and it happened so seamlessly you didn't even blink. AI is not some distant, futuristic concept just waiting around in a secret research lab somewhere. It is already the invisible engine powering the modern human experience. Section 1, the invisible everyday partner. Look, AI isn't some futuristic overlord. It's a quiet, incredibly efficient partner that's already completely embedded in our daily routines. Like when you unlock your phone with Face ID, an AI-driven system is scanning the intricate patterns of your face instantly. When you open up Netflix, there isn't a human curator sitting there predicting what you want to watch. It's an AI analyzing your specific viewing history. Google Maps aggregates dynamic data from thousands of sources just to optimize your morning commute. And hey, when your bank flags a weird transaction while you're traveling, that's AI recognizing a tiny anomaly in your spending patterns. All of these incredibly complex calculations happen in milliseconds, entirely in the background. But wait, it's not just about making our lives as consumers a little bit easier. AI operates at a massive industrial scale too. Consider this, and this is a really surprising fact. The DeepMind AI was actually deployed to manage the cooling systems for Google's gigantic data centers. By analyzing the data and predicting the absolute optimal cooling configurations, the AI reduced the energy used for cooling by a staggering 40%. I mean, that is enough energy to make a massive real-world impact. And it was completely driven by automated data analysis. Moving on to Section 2, the AI nesting dolls. You know, whenever you read about tech these days, you hear terms like AI, machine learning, and deep learning just thrown around constantly. The best way to think of them is like Russian matryoshka nesting dolls. Let's start with the biggest, outermost doll. Artificial intelligence is simply the broad, overarching objective of making machines smart enough to solve problems. Historically, this included systems that just followed rigid, pre-programmed human rules. So if a computer uses basic logic to play a game of tic-tac-toe, or if a supercomputer like IBM's Deep Blue uses programmed strategies to beat a human chess grandmaster, all of that is artificial intelligence. But when we pop open that outer doll, we find machine learning inside. Instead of a human hand coding every single rule, machine learning finds statistical patterns in structured data. It's like predicting housing prices from a giant spreadsheet. And then, nested inside of that, is the innermost doll, deep learning. Deep learning uses artificial structures, ones actually modeled after the human brain, to process massive, complex, unstructured data. So if you're generating a completely new image or translating live audio on the fly, you are using deep learning. Section 3, rules versus pattern recognition. Okay, the absolutely crucial point here is understanding how we moved from those rigid rules to flexible systems. Back in the day, what we call good old-fashioned AI relied entirely on human-written if/then rules. Think of a medical system programmed to say, okay, if the temperature is over 100 and the patient has a cough, then classify as flu. The problem? These systems were incredibly brittle. They literally collapsed the second they faced any nuance or ambiguity. Machine learning completely changes that paradigm. Instead of rigid rules, it uses a data-driven approach. It looks at millions of examples and just learns the probabilistic patterns entirely on its own. Which naturally brings us to a vital question. How on earth does a machine actually learn these patterns without explicit step-by-step instructions from a human? The absolute easiest way to visualize this is to think of a teacher using flashcards with a student. The AI model is fed a labeled dataset. Let's say thousands of medical images that are explicitly tagged normal or pronomia. The model makes a guess. If it's wrong, the teacher corrects it, and the system mathematically adjusts its own internal settings to minimize that error for the next time. All right, Section 4, inside a neural network. Let's zoom all the way in on that innermost doll, deep learning, and peer inside the actual architecture of a neural network. Structurally, it is a lot like a giant sandwich. We start at step 1, the input layer. You can think of this as the front door. It receives the raw data, like the individual pixels of an image or the text of a prompt you typed in. Step 2 is the hidden layer. This is the meat of the sandwich, and really the brains of the whole operation. This is where the information gets processed, patterns are identified, and features are collected. And finally, we have step 3, the output layer, which spits out the final prediction or decision. Now, the math behind all this magic? It's called forward propagation. Basically, information moves in one continuous direction, layer by layer through the network. At each step along the way, the data is mathematically multiplied by specific weights and added to a bias. It's essentially this massive, incredibly complex web of mathematical connections. During the training phase, these weights are constantly getting adjusted and strengthened to make the network's final output as accurate as humanly possible.
Section 5. Prediction, not true comprehension.
And this brings us to literally the biggest misconception about modern generative AI today. As one expert perfectly puts it, AI isn't intelligent in the way we are, it's predictive. Because systems like ChatGPT can produce such fluent, confident, and complex language, it is just incredibly easy for us to assume there is a reasoning, thinking mind behind the screen. But guys, there isn't. The machine has no beliefs, no reasoning, and absolutely no consciousness. It is, at its core, a highly advanced statistical prediction engine. To really demystify large language models, or LLMs, we just need to look at how they actually process information. They don't read words the way we do. They break text down into numerical units called tokens. If you type, "the capital of France is," the AI isn't pulling up a map in its head. It simply calculates that based on the billions of texts it was trained on, the token for Paris follows that specific sequence about 99.9% of the time. It is effectively an infinitely complex version of your smartphone's autocomplete. Autocomplete on steroids, basically. And this exact same predictive logic applies to visual AI too, like Midjourney, using a process called diffusion. First, the AI is shown an image, and static or noise is gradually added to it until the image is completely unrecognizable. Second, the AI is trained to reverse that process, learning step by step how to denoise the static back into a perfectly clear picture. So when you type in a wild prompt, like an astronaut riding a horse, it literally starts with a blank canvas of static and uses its learned probabilistic patterns to unnoise those pixels into the exact image you asked for. It's mind-blowing, but it's just math.
Section 6. Narrow, general, and super.
Okay, to wrap our heads around what actually exists right now in our world versus what's just theoretical science fiction, we need to categorize it. Literally everything we interact with today is narrow AI. It is highly specialized for very specific tasks, whether that's driving a car or generating a paragraph of text, but it absolutely cannot step outside its assigned domain. Now, the holy grail you hear about is artificial general intelligence, or AGI. This is a purely theoretical system that would have human-level adaptability. It could transfer its knowledge from, say, physics over to art. And way beyond that is artificial superintelligence, an entirely hypothetical concept where a machine surpasses human cognitive abilities entirely. We really need to anchor our expectations in the incredible value of the narrow AI we have right now, particularly in fields like healthcare. I mean, today, narrow AI is acting as a literal second pair of eyes for radiologists, spotting tiny overlooked fractures. It scans vast medical records for the early detection of sepsis before physical symptoms even appear in a patient. It powers virtual home wards so patients can recover comfortably in their own beds while being monitored remotely. And it's analyzing millions of chemical combinations to rapidly accelerate drug discovery. Because ultimately, AI is not a separate sentient mind. It's a tool. And tools require humans to wield them. The AI can highlight a tumor on an X-ray, sure, but the complex judgment, the nuance, and the deep empathy required to actually sit down and formulate a treatment plan, that remains entirely human. Thank you so much for joining me for this explainer. I really want to leave you with this one thought. As AI continues to amplify human capability, how will we partner with this incredible statistical engine to solve tomorrow's grand challenges?